Hi guys, this is lesson 4-5, all about scatter plots and lines of best fit. I think I'm going to do us a favor by condensing your lesson and your help video into one thing this time and give you more time to do your mid-chapter quiz that I made for you. So let me work through a few of these problems and just basically explain the lesson at the same time. So the first problem says the table below shows the number of hours worked and the amount of money spent on entertainment by each of 6 students. Create a scatter plot for the data. So when we create a scatter plot, basically all we're doing is plotting points. And so what we have here is some information. We have the number of hours worked and then the amount spent on entertainment in dollars. And so the student that worked 2 hours spent $4 in entertainment. The student that worked 5 hours spent $8 on entertainment, and so forth. So we're looking to see if there's a relationship between the amount of hours that someone works and how much money they spend on entertainment. So we're just going to plot these points. It might take you a few minutes to get used to using the Alex tool here. Number of hours worked, notice that that's our x. So we go over 2, and then 4 is the dollars. So we'll go up 4. We're going to plot a point right there. And then 5 and 8. So we need to go over 5 and up 8. And 7 and 9. And 8 and 10, and 11 and 13, and 12 and 11. So 12 and up 11. And this is a scatter plot. So notice that the dots aren't in a perfect line. They're a bit scattered, but they do have a little bit of a trend. Let me screenshot so I can write on this for just a second. So notice that we might be able to put a line through here kind of like this. And so we would call this a positive correlation. Wait a second. Oops. When we have a positive correlation, it just means that the line is going up, and there does seem to be some kind of relationship. In fact, I would call this a strong positive correlation. If the line is going down instead, we will call that a negative correlation. And not because negative means not, but because it's going down. And so we're looking just for a trend in information. So it does seem like there's a trend here that if students work more hours, they spend more on entertainment. This is probably fiction, so don't get worked up about it. Delete that and go back here. All I had to do for this was just to create the scatter plot. So let me just check and see if I got everything in the right place and go to the next problem. The data points on the scatter plot below show the amount of natural snow received and the amount of artificial snow made by a ski resort for each of 21 weeks. Draw the line of best fit for these data points. It doesn't have to be the exact line of best fit, just draw your best approximation. So our graphing calculators can actually calculate the supreme best, exactest line that fits through the middle of those perfectly. We can't really, but we can eyeball it. So basically I'm just going to grab my line and place my first point somewhere where it looks like it's going to go through pretty good, and use that second point, and I'm just eyeballing my way through there. It doesn't have to be perfect. And I would call this a fairly good negative correlation there. And what it's saying is the more natural snow we get, the less artificial snow the ski area makes. And so that makes sense. If you have enough natural snow, you don't even need to make artificial snow. Ta-da! All right, the scatter plot shows the number of hours worked and money spent on entertainment for each of 24 students. Seems to be a theme in this one. Also shown is the line of best fit for the data. Okay, so they've already drawn the line in. We're just going to answer some questions. For these 24 students, as the number of hours increases, the amount of money tends to, and so what we're going to do is look, as the number of hours increases means look this way. What is happening to our amount of money spent? It's going up, right? So as my hours worked gets more, my amount of money spent is going to go up. So we'll look for that option. It's going to increase. For these 24 students, there is what kind of correlation between the number of hours worked and the money spent? Well, that definitely looks like a correlation. It is a positive correlation because it's going uphill. Using the line of best fit, we would predict that a student working 10 hours would spend approximately how many dollars? So we're just going to look it up on the graph. So we want to see about if a student is working 10 hours, where is that about? 25. So we're going to say that based on the line of best fit, notice we don't have a data point exactly there, but we could estimate that a student that works 10 hours is going to spend $25 on entertainment. So we'll see if there's something close here. We'll go with that and check. And the following one says, the scatter plot shows the number of years of experience and the hourly pay rate, Y, for each of 25 cashiers in California. So I'm looking at this going, okay, it looks like as we get more years of experience, we're getting more pay in dollars per hour. So we're going to use the equation of the line of best fit, Y equals 0.95x plus 8.15 to answer the questions below. So let's understand something about this equation before we go any further. So Y equals mx plus b, right? So in this case, we have Y equals 0.95 times x plus 8.15. This is our slope. That's our rate of change. Right? That's our rise over run. And then this is our y-intercept. It is our starting amount. So if you look over here, we have a y-intercept of 8.15. And that would be my starting pay in dollars per hour, right? And then as I go over, for each year of experience, you can think of this like this if you want. For each year of experience, I'm going to go up 0.95. So I am going to increase. That seems like interesting. Times the year. So 0.95 times the year. We're going to rise and run. Okay. The decimals got me thinking, so I will stop here and go back to the other screen so we can look at this. What is the predicted hourly pay rate for a cashier who doesn't have any experience? Okay, so doesn't have any experience is 0. And at 0, remember, we have a y-intercept there at 0. And so you can always look for the b number, y equals mx plus b. And 8.15, let me move my type, would be what we start at. 8.15 is our starting amount. That's when we have no experience. Okay, for an increase in 1 year of experience, what is the predicted increase in the hourly pay rate? Well, we could look at it and guess, but we're going to say it exactly from the equation because y equals mx plus b, and m is our slope and slope is going to be our increase every year as we go along. So let's see, we're going to type in 0.95 is the increase in, interesting. So not quite $1. What is the predicted hourly rate, pay rate for a cashier with 5 years experience? So to do this, we're going to call up a calculator and we're going to use this equation. So 5 years of experience is an X. So we're going to go 0.95, whoops, 95, oops, I've got weird things going on here, hang on. Decimal, 95 times, plugging in 5 instead of X, plus 8.15. So does that make sense to you? There is our Y equals 0.95. X is 5 plus 8.15. And what we're going to get when we hit enter is Y. That equals Y. So equals 13.25. And we should ask, does that make sense? To that a cashier with 5 years of experience would make. So I go up 5 years of experience, and yeah, the line crosses between the 12 and the 14, and so that should be good. Check. Uh-oh, it doesn't like me for some reason. I have forgotten something somewhere. Let's just make sure I typed in everything right. Often it is my calculator. So I'm just going to calculate that one more time. We had 0.95 times 5 years of experience, and then plus 8.15 equals 12.9. So I'm not really sure what I did. You were probably watching me and probably saw whatever that was. But we want to say $12.90, which is close enough to still be on the line. Try again, and we got it. All right, so do that one carefully. I took off the problem number 5, where you calculate the line of best fit, not because I think you can't do it, but because it's so easy to type in a number that the problem, like, there just seem to be problems with trying to get it right or getting what the program wants you to say, and that's not the point. So we will do some calculating lines of best fit later in a different format. So hopefully I took that problem even off of your topics. Hopefully. I've seen those things turn up again. If you're just trying to get one right so you can move on, let me know. I will work it with you. So anytime you have one of those grueling problems, we can do it together. So just let me know.